thank you for your time, Adelaide.
Yeah, thank you. Thank you, Sonny. Let me start my presentation by saying thank you to IEEE Computer Society, Western Australia page, and whoever was involved in arranging this seminar. And thanks, only a handful of people attended here today for the seminar. Today I'm going to talk about long-term IS cloud service selection using short-term trials. This is one of the pieces of work I have done in my PhD, and I chose this work. It's kind of one of the most representative work that actually highlights overall the research that I have done. Let's see. So this is the outline of today's talk. So I'll give a little bit about, I'll talk a little bit about me, although there's a long introduction. Thanks for that. And I'm also introduce my current lab, CREST, and then we'll jump into the motivation of the research problem, some of the research challenges we have to address in this work, proposed solution, and evaluation, finally, the limitation of future work. This is me, it's Sheik Mohammad. I'm currently a postdoctoral researcher at the University of Adelaide. I'm also a cybersecurity CRC theme postdoc, and my current research interests services computing, cloud computing, edge computing, IoT, and distributed ledger technologies. So, introduction to CREST. So, CREST stands for Center for Research on Engineering Software and Technologies. So, here we leverage existing software engineering technologies, analytic reasoning, natural language processing, machine learning tools, and other techniques to develop secure and integrated platforms. The more details about our lab can be found in the link. These are the link for the CREST. We have 5 clusters in CREST targeting different areas. Now we have a software security intelligence, security orchestration and automation cluster, socio-technical factors, big data analytics, and TIPS, which stands for trusted information processes and services. So this is the composition, the CREST team. So our director is Professor Ali Babar. We have a few faculty members, several postdocs, and a bunch of PhD students, research engineers, and collaborators. So you can see it's a pretty big team, and we also have a few position opening. If you know anyone who is interested, you can refer to our website. Let's talk about my research now. I will start by talking a motivation scenario and the research problem. So imagine you are a CEO in a large organization, and this organization wants to migrate its IT infrastructure into the cloud and manage for a long period of time. Here, long-term means the refers to the reservation-based contract rather than the pay-as-you-go. The reason you want to move, your organization wants to move migrate to cloud because it gives several advantages such as low maintenance cost, high performance, and high productivity. And we have several cloud providers nowadays: Microsoft, Google, Amazon, DigitalOcean, and many more. And these providers virtualizes computational resources such as CPU, memory, network storage, and so on, and offer them as various cloud services such as virtual machine, virtual storage, virtual networks. We call this type of services IaaS, or infrastructure as a service. Now, as a decision maker, you'd like to choose the service or the service provider that best fits to your organization's requirement and long-term requirement. So during the selection, one of the most important criteria is the performance of the services provided by different providers. So the performance is typically represented by the quality of services. That means virtual CPU speed, disk read-write throughput, memory bandwidth, scalability, availability, and so on and so forth. Different providers may offer the similar service, but their performance could vary very significantly. Now, the challenge is that most of the providers offer very limited information in their advertisement. So either they provide only a limited number of key attributes, or they provide very they represent information in a way that sometimes could be misleading to the consumers, like those internet providers. They may say that the performance is 100 Mbps, up to 100 Mbps, but in practice, you hardly find 100 Mbps every day. So the question is, as a decision maker, how do you select, or how do you go in a long-term commitment, given that the information is very limited? This is where we start investigating, and we formulate our research objective, which is selecting the best cloud service for a long-term period according to a consumer's long-term performance requirement, given that the service provider disclosed limited performance information. Here, performance. By performance, we mean the performance of the common QoS attributes that can be directly measured using application workloads such as virtual CPU, speed, disk read-write throughput, and so on. So we started our research by an interesting insight in the real world. So we found that most of the provider, most of the at least the major providers, offer free trials, free short-term trials to entice the potential consumers. For example, Google offers $300 credits to their consumers so that they can spend this $300 credits on various services and test their application workload for a short period of time. And a consumer then can monitor the performance of different providers and select the best one that fits its performance requirement. But the challenge is, there are a few challenges. It's not that straightforward, because the long-term aspect of this selection. So we found there are two. In this work, we identified two key challenges. So number one, the temporal restriction. So the trial are essentially offered very short period of time, and in order to select a consumer, to select a provider, cloud service provider, for a long period of time, you need to test all sort of workloads that you're going to be used in future. So let's say you want to use the workload, you want to use a particular service for 1 year, and within 1 year you can use a wide range of application, diverse set of workloads, a different number of workloads with different distribution. And it might be very challenging to test all type of workload in a short trial. So this forms our first research challenge, which is temporal restriction. The idea is how to test long-term workload in a short trial. And the next challenge even is harder than the first one, which is the performance variability. So let's say we perform the trial in January, and how to be sure that in the next month the performance could remain the same? The reason is most of this provider operate in a multi-tenant environment. Therefore, the performance may change over a period of time. However, this information are not readily available in the advertisement or anywhere else. So how to deal with these two challenges? So in order to address these challenges, we come up with a set of solution or set of tools to help a consumer to make a long-term decision. So our proposed solution consists of 3 parts. The first one is a significance-based trial scheme, and the next one is IS performance signature, and the third one is finally the signature-based IS selection. So I'm going to walk you through all these 3 steps, 3 set of solutions. So the first challenge, we talked about the temporal restrictions. So that means you have a very short period to perform the test, test your application, but you have long-term workload. So how can you test your workload in a short period? So the workload can be represented by service request attributes such as resource demands, request arrival time, and resource utilization, and so on. And one of the way we can approach to this challenge is to, instead of trying to test all sort of workload, we can test a subset of the workload during the trial. And when we select the subset of the workloads, we want to select the workloads that are most important to the consumer or the most significant workloads. And the question is, how do you define or how do you measure which workloads are significant that you want to test? So we defined two ways. We defined two criteria to measure the significance of a workload. The first one is frequency-based significance, and the second one is the resource consumption-based significance. And we can extend this concept of significance more by adding different criteria. But in this work, we only considered these two mainly. So what is the frequency-based significance? So in this frequency-based significance, we consider the workload that may occur the most in a long period of time. That means the most frequently occur workloads are considered the most significant workloads. And the next one is the resource consumption-based significance. That means the workload that are most resource hungry in terms of CPU or storage or network or memory. Those are considered the significance, the resource consumption-based significance workload. Based on these two concepts, we define three types of workload generation techniques for the trial. So the first one is frequency-based generation, where we select most frequently occurred workloads in the trial. In the next one, we have resource consumption-based generation. So we select the most resource-hungry workloads for the trial. And finally, we have the mix generation. That means we mix up the frequency-based generation and the resource consumption-based generation both. Okay. So now let's say we have performed the trial. Now the next question is how to address the performance variability because we don't know the performance would remain the same or not. So when we do research, we often get inspired from our observation from the surroundings. So we found the concept of signature is widely used in many domains, such as computing, cryptography, and security. The term signature often used to represent the unique characteristics or behavior of an entity, object, or work. For example, McDonald's has its signature burger that represents its unique taste. Some of the applications of signature includes identification, authentication, and anomaly detection. And we decided to utilize this concept of performance signature to represent a provider's or a service's long-term performance. So we define the signature in a way that represents the long-term performance of a service, and it represents the relative performance over time. That means it represents the seasonality and the trend instead of the actual performance. That means we cannot directly use the signature. It contains very limited information, essentially just the trend and the seasonality over time. And we use a matrix to represent this signature. So where each row is corresponding to a QS attribute and each column represents the timestamp and each cell represents the value of this signature of service. Now the question is, how would you produce such signature? Or why do I get this signature? So now I'm going to describe how we can actually obtain this kind of signature. Imagine there are three IS providers and offer three types of functionally similar, like the virtual machines, virtual machine A, B, and C. And these providers also offer free trials. And there are past trial users who utilize these virtual machines to test their applications over a period of time. And would like to utilize the experience of these trial users to produce the signature. That means we want to capture the performance trend over time and the seasonality from this experience. The issue is that these providers may not want to share, these consumers or these trial users may not want to share their experience publicly to protect their privacy, security, or the conflict of interest with the provider. Therefore, we can assume that this experience can be shared with a trusted non-profit organization. And example of this kind of TNPO exists in public sectors where information about individuals needs to be collected to better service delivery. For example, we have a health research institute often collect patient data about patients to provide better health services or investigate a particular disease. So we assume in this work there is a trusted third party who collects information over a period of time from this trial user's experience and produces the signature of the services. Now we have the signature and we also have the trial experience. Now we utilize these two to help the consumer to make a long-term decision. So in this part, signature-based IS selection, we have three parts. Number one is trial confidence, and we have also signature-based performance discovery, and finally we have long-term IS selection. The measuring confidence, first we need to measure the confidence of the trial. The question is, what is the confidence? So, because as we already know that the performance may change over a period of time, therefore we need to measure the trial confidence, and which means that whatever the experience or whatever the observation the trial user gets from a trial, how confident or how representative of this experience is compared to the actual performance. So the confidence is a way to measure the similarity between the actual performance and the trial experience. And the way we measure the confidence is using the signature that we have of a particular service and the trial confidence. We take these two and we represent both of them as a time series and then try to perform the similarity matching between the trial experience and the signature. When these two matches, we assume that we consider the confidence is high if the similarity matching is high. If the similarity matching is not very high, then we discard the provider. In this work, however, in some of our other works, we consider how can we still utilize that experience to make an informed decision. Let's say we have measured the trial confidence, then the next step is to discover the actual performance. Remember we said the signature we represented using relative performance. That means the signature represents the performance changes over a period of time. So if we have performed in 1 month using the signature, we can transform that performance into another month. We can project it into any other month. And that gives us the discovered performance or the expected performance of that service. And finally, we have the expected performance over a period of time, and we also assume that we know the consumer's long-term QS requirement, performance requirement. So we represent both of them as a time series, and we measure the distance between the expected performance and also between the expected, sorry, my slide changed, expected performance and the actual performance. So finally, we evaluated our proposed approach based on 2 aspects of this approach. Number one is the signature-based performance discovery. That means using the signature, how accurately we are able to discover the actual performance. So we measure the prediction accuracy, we compare with the baseline approach, and we also try to look at different trial schemes. The significance-based trial scheme. What are the effects? We also evaluated the long-term selection. That means we rank the provider and we try to estimate we evaluated the ranking of our ranking accuracy. And we compared with other type of ranking, like if we were to talk about only short-term ranking, that means if we just decide based only on the trial without considering anything else. And we also use a baseline approach. For the data set, we collected a few data sets from Microsoft Azure, Google Cloud Platform based on benchmark on HTTP perf. We also collect data from some private cloud providers such as Eucalyptus Cloud Traces and Speck as benchmark results. On the left-hand side, we have one of the baseline approaches, which is we are calling long-term performance discovery. That means LPD. In the baseline approach, what we did, we use the different trial strategies. We project it into the free trial period, and then whatever the performance we get, we try to extrapolate linearly over a different period of time to estimate the performance. But it doesn't actually consider the performance variability over time. As a result, as you can see, we have a normalized root mean squared error distance from the actual performance and the discovered performance, which is pretty high. Compared to this, we have signature on the right-hand side. We have signature-based performance discovery approach. We can see that the performance, discovery accuracy, predicted accuracy is higher than the baseline approach. And you can see the effect of different type of workload. Most of the time we see the frequency-based workload perform better because it tried to test all sort of the most frequently occurred workloads compared to the resource-hungry workloads, which is also interesting insight. And we also rank the provider and we measured the ranking accuracy. We have four metrics. The first one, we have the expected ranking. That means based on the actual performance and the distance between the consumer requirements and the actual performance. We try to measure the ranking. So which is the first one, the expected ranking. Then we have the short-term ranking. That means we only use the free trial and rank the provider based on the free trial, which is the next line. And the third line is LPD. That means one of our baseline approaches. And finally, we have SPD. That means signature-based performance discovery. From this, we can see that the first one and this last one has the highest similarity compared to the other one. In the last one, we have only one flip. P3 and P2 are here. P2 and P3 changes in the ranking, and the other two approaches are not really consistent compared to the actual ranking. Some of the limitation and the future work. We assumed in this work that the organization or the consumer knows its workload in advance for how long they will use the service. In reality, the workload may change, business model may change based on the business model or any other reason. Also, the performance of the cloud service provider was represented by its signature. Now, the signature may need to be updated when performance of the provider may change. So in this aspect, we need to find a way how to detect the performance change of the cloud providers. Also, we can investigate different trial schemes when we don't know, or when we don't know details, or when we don't know the nature of the workload, or that the workload is dynamic. That brings me near to the end of my presentation. So I would like to acknowledge Professor Atman Bogataya from University of Sydney, who was my PhD supervisor, and my co-supervisor, Dr. Sajib Mistry. Both of them guided me to carry out this work. And also, of course, the lab where I used to work, Sensor Cloud Services Lab. Some of the related publications of this work is here. Most of them are in archival also, so you can get the preprint from there. If anyone interested to know more details, I'm happy to answer any question after the presentation now or via email. Both of them are fine. So that's all of my presentation. Thank you very much, everyone, whoever attended and listening to my presentation. Is there any question?
All right. Thank you very much, Sheik, for the very nice presentation. And if any of the audience would like to have a question for Sheik, please feel free to ask Sheik. Is there any question from the audience?
Okay, Fattah, superb.
Yes.
Yeah, of course, if you're presenting it live, we will definitely clap and you will heard a lot of applause. Just one thing I want to understand. What's the implications of your work, like the significance? How we can, I know that you target only one area. Is there any way it could be extended or applied in other areas as well?
Yes, definitely. Definitely. The more I think about my work, like, you know, during my PhD, the focus was very narrow, the targeted area, and I also only targeted in that area. But the more I think, there are several aspects of this work that is actually applicable to many existing works. So when we talk about long-term aspect, one of the aspect is long-term. So even in the real world, even if you want to buy a car, let's say you want to purchase a car or you want to purchase a phone, it's essentially a long-term commitment. And even though there are many, what should I say, YouTube reviewer who compared this different kind of product, but in our research, when we talk about edge computing, fog computing, or any other, like recently I'm working on blockchain, and let's say you want to develop a distributed application and you want to choose a blockchain. And it is essentially a long-term commitment, not long-term, it's a lifetime commitment, because once you put the data in the blockchain, you cannot remove it, or at least easily remove it. So this is one aspect. And another aspect is the concept of the trial. So we also find that this trial in real world is very popular. I don't know whether you remember, previously we used to have a free trial version of the even software. So software engineering people actually worked a couple of years ago, or at least almost a decade ago, about free trials for the software technology. So when they provide software, how it could, what kind of trial model they should use. But my perspective was from the consumer perspective. So we can leverage this trial techniques as well. So we and most of the time, when people perform the trial, they think like in terms of benchmarking softwares or software testing in cloud. They find that they use most resource hungry or they perform some sort of stress testing or resource hungry workloads. But in our experience or in our experiment, we found that it's not always give you the best result. Sometimes, because sometimes you may not use the high resource consumption workload. So you need to be very careful when you test this workload, and it can be applicable to other areas as well when it comes to testing. And finally, we have the concept of signature, which is incredible, actually. The more I think about the idea of the signature, how to represent the performance behavior, and it could be, and it could be applicable to other areas as well. And it has other application in some of my works. As you know, we work with the performance anomaly detection with the signature, performance change detection with signature. We can perform this work. And in security domain, the concept of signature is highly popular. But there are some interesting challenges related to signature that we can investigate, and in any other area.
Okay, that's good. So about the signature, like to generate a signature, we need data. And do you need a substantial amount of data, or we could bootstrap data from some other domain and start building some kind of signature and then build upon that?
We do need data, but the approach we need a lot of data when we have if we were to use machine learning types of approaches. But we try to, because in cloud, as you know, that we do not have much data in publicly available, and at least the data that fits to our requirement. So I try to come up with simplistic approaches to produce the signature, which doesn't require a lot of data, but the more data you have, the better accuracy you'll have. In terms of when you talk about the curating data from other sources, then we need to, I haven't considered that curating data from other like transfer learning, something like that, right? If I understand correctly, but it would be hard because it has to exhibit the similar behavior, and in order to generate the signature, you need the performance from, like, understand the behavior of the particular provider, which would be hard to find from any other domain.
Thank you.
All right. I think we have a question from Ridawan. Ridawan, did you want to ask Sheik a question?
Yes, definitely. Thank you, Dr. Fattah, for your nice presentation. It was really a good insight regarding the kind of workload and performance analysis as well in a cloud environment, and it is definitely good work. So actually, my question is on that, have you considered IoT streams driven workloads while doing the analysis of this kind of long and short term leasing of cloud resources? And if not, then what should and how should be your system can be modified to actually digest this IoT streaming?
Thank you. That's a very interesting question. No, during my PhD, I did not consider the IoT stream or any sort of streaming data. I didn't consider. That could be an interesting way to look at it. But when we did develop the approach, we tried to use an abstraction to represent the workloads, so that we can fit different type of workloads with different granularity. So that means you can model your workload in terms of number of requests per minute, per second, or per hour. And you can also play with the distribution of the workload. That means you can work with uniformly distributed workload. You can work with the heavy tail distribution, this type. For the streaming data, we need to find a way to how can we represent or formalize this streaming data to this context. That could be interesting. And if we can do that, the work should be applicable.
Yeah, that's really good. Yeah. So because for IoT streams, the frequency of data streaming can change very frequently. In that case, this kind of long and short term, if we have that kind of analysis or during this leasing of cloud resources, that would be really interesting. So
Yep.
So if any kind of options opens, we would definitely expect you in collaboration with Kartin to look into this matter and solve this problem of IoT streaming on this kind of issues.
Of course, that would be great. That would be great. Of course, we can discuss it further. about the IoT streaming data. Let me think first. I need to think actually more details that if we can have a good opportunity to collaboration, particularly in this area. If not, maybe in other area.
Yeah, that's good. Thank you, Fattah. Thank you for your nice presentation.
Thank you very much.
All right. Are there any questions from the audience? All right. So if there are no other questions from the audience, then I ask you a question, Sheik, if you don't mind. So
sure, of course.
Yeah. So my understanding of cloud computing is that the quality of service or the level of service, right, is usually associated with the level of subscription that you pay, right? For example, if you pay more money, you get like there could be a difference between 99.99% and 99.9999%, right? That's the at least with AWS, which I have a chance to to talk to the representative from AWS, right? So for example, like at the corporate level, for example, it is different from like an individual user, right? Where you just like go subscribe, right? But like for example, if you work at a university, for example, and you subscribe to AWS, and they obviously have different pricing structure and level of service, right? So when you did your experiment, I suppose you use a free trial, and that is basically just a consumer level trial.
Yes, that's correct. But we try to use the most public and private cloud both. So in the private cloud that we had, that is actually organization level. So that had thousands of users. But in the public one, yes. So when I tried to collect the public data, it was end user level. Yes.
Okay. So when you compare them, are you compare them on a same sort of pricing structure, or like how do you compare them? So how do you make the comparison like more, I guess, fair between different sort of pricing structure?
Okay, so we try to select the service that has same price. Remember, we also try to compare between different cloud providers. So we try to select the similar price or at least similar resource configuration on the advertised information, we choose from different providers who has the similar resources, and based on that we compared. So therefore, the price was not the issue because we choose the similar prices for the cloud services. But what you said is very true. If you pay more money, then you can get better performance. But if you look at the advertisement, the service level agreement mainly talks about the availability, nothing else. If you open the service level, if you go to their, so they say 99%, 9.99 availability. But what about the other criteria? One of the interesting aspect that I found during the virtual machine deployment, VM start time can be significantly variable from provider to provider. And they don't mention it, but it's a significant issue for your cloud application. So when you need to scale your application, if you want to start another virtual machine and it takes a long time, your application eventually is going to be slow. And nobody tells you this kind of things in the advertisement or even in the corporate level, because the people who are in, at least I believe, the people who are in consultancy, people who consultant and who negotiate this kind of things about the technical details or the technical aspects on the lower level, it's very hard to expect they would be able to show the details.
Okay, yeah. So your advice, let's just say, like, if any audience of your seminar here, it's just like a normal consumer, right? And they just want to, take the take the message from your research and say, I'm going to, compare between, Amazon and, other providers, for example, right? So the take-home message for them. The question they want to ask you is like, they usually come with free trials. So first of all, would that be enough? The duration, is it 30 days? I'm not sure how many days the free trial is, but like, is it enough for them to make a decision on long-term commitment with the cloud providers? And when we say long-term, are we talking about a year or 2 years or how many years? And what from the user perspective, what do they need to measure in order to make decision on which one is better for them?
Oh, okay, that's an excellent question as well. Yes, the work that I have done, it's the motivation of the work from the organizational level. The reason is organizations more care about the performance because their scale is very large. So minor fluctuation in the performance could lead to a significant issue. In terms of the end user, they can very often do not see it until they use it, the performance issues. So the question is, the issue is that you don't have any performance information at all. So compared to that, whatever the free trials period you have, whether it is 1 week or 1 month, it is always possible to make a best use of that to help to make a better decision than knowing nothing. And whether it is enough or not, it would depend on how much performance would change over a period of time. And it is always a good idea if it is possible to have a look at what other people experienced, like not only performing trial by yourself by own. Also, you need to consider what other people have done, because whatever you did, it could be possible that if you do not, let's say for example, let's say you are using only for hosting a website, and the number of people when you test it is not very high, and you, based on that, you make a decision. But in future, you may use your cloud service for other purposes as well. And if you have a look, someone who used this for benchmarking, like mobile phone, or use some online selling platform, then you can get interesting insight from other people's experience as well. And the concept of signature essentially captures or summarizes the experience of other consumers, but you need both. You cannot like both hand in hand. You cannot do one without another.
All right. Yeah, thank you very much for that information. Okay. All right. Are there any more questions from the audience? All right. So if there is no further question from the audience, so may I please ask everyone to, I guess, do a virtual round of applause. I think there's a icon somewhere. Yeah. Okay. Yeah. Thank you very much. And yeah, and to say thanks to Sheik for making your time available to share with us your research story, and yeah, a very great presentation. Thank you very much, and hope to hear more from you in the future.
Yeah, thank you very much. I just have one question. How do I get the recording of this?
No problem. I will download the recording, and I will send the link to Hannes, and who will forward you the link.
Okay,
yeah,
thank you. Thank you very much. And thank you everyone for attending again and having me over. Good to meet you all.
All right. Thank you everyone for being here today. Yeah. Thank you. Bye.